Alors, mes amis, comment ça va? Je voulais bien faire ces vidéos en français, mais à ce moment, je n'ai pas de vocabulaire suffisant pour le faire. Peut-être à la prochaine. Alors, je vais faire une vidéo en anglais parce que j'ai besoin de pratiquer la langage. Hello, my friend José Carlos Pereira. How are you doing? I hope so much that you are doing so well. And first of all, I want to thank you so much for posting this nice question at the group. I think I have not enough time to make all these three questions you posted, the question A, B, and C, but I think that I can get the answer to the question A. And so after that I'm going to give some ideas about the question B and C, and in the next video I will continue. Okay, that's okay. So thank you, Jose, and I hope so much that you are doing so well. Okay, so let's go to our math question. Let's consider the function f, let us say, which domain it is from open interval -1 to plus infinite, and the function is defined as you can see over here. Okay, it is a function f defined by branches, and when x it is in the open interval -1 to 0, it is equals to x plus 1 over logarithm of x plus 1, and when x is greater or equals than 0, it is x squared exponent 2 minus 3 times x. Okay, let's go to study the existence of the asymptotes to the graph, and if there exists, I'm going to get the equations of them. Okay, so first of all, I'm going to put an eye in about the vertical. Okay, vertical asymptotes. Let us say something like x equals a constant k. Okay, and to do this, I'm going to look to these points over here, -1 and 0. Okay, and so I'm going to take the limit. The limit. Okay, when x approaches -1, but as you can see, the open interval it is -1, 0, and if x approaches -1, it will become for sure by the right. Okay, so I will have x approaches -1, and I'm going to put here the sign plus. Okay, up x plus 1 over logarithm of x plus 1. Let's look to this. So if I substitute x by -1 in the numerator, I will get for sure the value 0. Okay, and at the numerator I will get, let me see, something like logarithm of 0, but it is 0 with a sign plus or a sign minus. It is quite simple to understand, because if I'm approaching x to -1 by the right, it is I'm subtracting something to the value 1. So I have a positive number. As you can see, I'm going to put here the sign plus. Okay, and so in this case, the logarithm function, as you know, it is simple to draw. It is something like this, and it approaches to the minus infinite. So I will have something as 0 over minus infinite, and this is 0. If this is 0, so when I have x equals 0, it is not a asymptote. So I'm going to try now at the value x equals 0. Okay, x equals 0, and so let's go to take first of all the limit. When x approaches 0, let me see, by the left. Okay, by the left. All time I draw something like this because I think it is more simple to understand. You see, all time I tell that to the students, but they don't care about that, you know. So now I will have here x plus 1 over logarithm of x plus 1. Okay, so let's go to substitute x by 0, and so for that I'm going to get something like 1 over logarithm of 1 logarithm of 1. Let us know if I have here let us say 1 plus or 1 minus. As you can see, x is approaching 0 by the left. Okay, it is lesser than 0, so I'm subtracting again. Something to the logarithm when the logarithm is taking the value 1. It is quite in the point 1, but it is not. It is in the neighborhood, you see, of the point 1, but it is at the left, let us say. So this value, I can say it is minus infinite, but in this case, if it is minus infinite, not minus infinite, I'm so sorry. I'm so sorry. It is not minus infinite, because logarithm of 1, it is 0. But as it is a little bit lesser than 1, it is, let us say, 0 with a sign minus. Okay, and so it will come minus infinite. Okay, so I can say that x equals 0. Yes, it is. Of course, it is a asymptote, but it is a asymptote, something like this. It will come for sure in the graph, something like this, when x it is in the open interval -1 to 0. The function, it will be something like this, you see. So then the other side, it will begin the other branch of the function f. So now I get one equation for the vertical asymptote. Okay, and it is x equals 0, but it is only asymptote at the left. So now I'm going to calculate let me see, maybe the horizontal asymptotes, because I think that is the limit of this branch when x approaches plus infinite. Let's go to see about that, okay? And also, why not? I have here the answer. I did not look, but I have here the answer. I think I'm in the right way, so I'm going to take the limit when x approaches plus infinite of x squared, okay? X squared exponential, which exponent it is 2 minus 3 times x. So let us say in this way, why not? I'm going to substitute x by plus infinite. I will get plus infinite, and I will have the exponential, which exponent approaches, as you see, minus infinite, and the exponential, which graph it is something like this, will approaches 0. So I have something like this, and I must work in this limit. I'm going to work, okay? So I'm going to put this limit in this way, because it will be more nicer to understand. It is x squared over a, and I'm going to change the signs, because I'm going to put the exponential at the denominator. So I must put 3 times x minus 2. And now there is a limit. There is an important limit, which is the limit of, let us say, exponential exponent x, and here I have x exponent p when x approaches plus infinite, this is equals to plus infinite. Of course, if I have the inverse, it is quite simple to understand that the function will approach its 0, because 1 over plus infinite, it is 0. So I must figure out this limit so precisely like this one which is over here. So I'm going to make a change of variable. Let us say 3 times x minus 2 equals t. And when x approaches plus infinite, t also approaches plus infinite. I think it is very easy to understand. So the value of x, it will come 2 plus t over 3. So I will get the limit when t approaches plus infinite of exponent t, and now I have this over here, and this over here. It is simple to understand that it is 2 plus t over 3 squared, but I can of course I can develop this expression when t approaches plus infinite. Let me make these calculations. Here I have 9. You see, it is 3 squared. It is of course it is 9, but it is at the denominator. I'm going to put here 9 times exponent t, and I'm going to develop, you see, this square. It will come 4 plus the double of 2 times t. It will come 4 times t plus t squared. And now I can use important property. It is the distributive property in relation to the division to the left, and I will have of course the limit, and because also the limit of a sum is the sum of the limits, I will get t approaches plus infinite of 4 over 9 1 over exponential plus again 4 over 9 I'm sorry, t over exponential exponent t plus t squared exponential of 9 times exponential exponent t. Okay, so now it is very simple to calculate the limit. Here it will come 4 over 9, and this limit when t approaches plus infinite, exponential also approaches plus infinite, and I will have something like 1 over plus infinity, which is 0 for the first one. For the second one, looking to this limit over here, I have the inverse, so I will have 0 again, and for the last one, of course, I have 0 again. And yes, I can say that there is a horizontal asymptote, which is y equals 0. And so I think the first question, it is done. I am so sorry, but I have not the time to continue. But I think if to show that the function f is decreasing in this interval, and then it is increasing this one, and f of 0, it is not a point of a maximum or minimum. I must apply maybe to the definition of that, and for sure I will have something which is not according that definition, but I might use the first derivative. I won't say derivative, and making a board of Cygnus to study the the increment of the function f. In the last one, and because in this interval, which is the interval from 2 to 3, I have this function over here. It is a continuous function, and I can use the Bolzan theorem. Looking to this part over here, the image of xa, which exponent it is -3, -1, it will lies for sure in the first branch. I think it is very easy to calculate, I think, and then I would apply to the Bolzan theorem. I will make that in the next video, okay? For now, it is all. Have a nice afternoon, my friends, also to Jorge Penalva and Paulito Mateiro. Bye bye, my friends.